Hi, good evening. How are you? Today's video we are going to evaluate two nice expressions. The first expression is a sum of sine theta, the theta from 1 to n, which is sine 1 plus sine 2 and so on until we get the sine theta. We have another expression which is cosine, the sum of cosine theta, the theta from 1 to n, okay? Equal cosine 1 plus cosine 2 until you get the cosine theta, right? Okay, if you want to take try, just pause the video when you want to come back to see how to solve this problem, right? So before we start, notice, okay, I would like to remind you about some expressions. The first thing we should know, we are going to use the number complex as a tool in order to help us to find the results, okay? So these equations involved in this form. So we have exponential I theta equal cosine theta plus I sine theta. Keep in mind I is a number complex. Every single number complex has two parts. The first part is a real numbers. The second part is imaginary numbers. Okay? So we have three equations. The first equation, exponential I theta equal cosine theta plus I sine theta. The second equation, cosine theta equal exponential I theta plus exponential the power of negative I theta over 2. The last equation is a sine theta equal exponential I theta minus exponential negative I theta over 2. Okay? Those three equations can help us to solve this problem, right? There is another additional thing here, which is this expression. This expression is a geometric series. The geometric series, we will see it in a moment now to see how this geometry series work here, okay? Let's start now. We have the sum of exponential I theta from 1 to n, right? Equal sum cosine theta from always from 1 to n plus I. This is the number complex now. We are using the number complex from the beginning, okay? So it is a sum. After that is sum of sine theta, okay? Theta always from 1 to n. Here is the issue here. So we are writing this expression as you see it here. So we are going to evaluate these two parts. The first part is a real number. The second part is an imaginary number. The real numbers, okay, is this one. That's what we are looking for. There is a second part is an imaginary number. That's what we are looking for as well. So this is the whole thing. The sum of exponential A theta. This is number complex, contain two parts, real numbers and imaginary numbers, right? Let's expand this one to see what's giving us here. So the sum of exponential A theta always from 1 to n, equal, let's log in our theta into theta to see every single term, okay, individually. So let's put I, let's raise to the power 1 plus second term I to the power 2 and so on until you get the last term, which is exponential I the power n. This one we are not leaving it like this. We are to put the exponential I outside in the front as a factor, okay? So let's put it I 1 plus exponential I plus exponential I the power 2 and so on until you get the last term. Here is n minus 1 because we take in the I outside, exponential I outside. okay, in the front of the whole thing. So this one right away is a series geometry as you see it here. So our exponential I, we're gonna put it like this: exponential I n 1 minus exponential I over, as you see here. I'm gonna do this one now. I will explain it in a little bit, okay, in one second. So exponential I, let's factor this one. I want to play around a little bit here, and over 2 exponential minus I n over 2 minus exponential I n over 2. Let's factor here on the bottom as well. Exponential I over 2 exponential minus I over 2 minus I over 2, right? Okay, let's explain now. So we are putting exponential I n over 2 outside and multiplying by this one, okay? If you distribute this one, you will see exponential I n over 2 times exponential negative I n 2 equal 1, right? The second term, if you multiply this one, exponential I n over 2 by exponential I n over 2, you will see exponential I n, right? It's the same thing on the bottom. Let's factor, let's take this one outside. Exponential I over 2 factor, put in the front of the whole thing. So exponential negative I over 2, if you multiply this one, it gives you 1, as you see it here. The second term, if you multiply this one, it gives you exponential I. So let's keep calculating this one, exponential I. Let's erase this one on the top to see how it become now. So I over 2 and minus 1, right? So the top one, let's take the negative sign outside. This one becoming the front. The first term will be on the back term, okay? The same thing on the bottom. So it will be the negative sign in the top one. On the bottom one there is a negative sign as well. Negative sign over negative sign equal the positive sign. So let's switch the terms and over to minus. I will explain a little bit why I'm doing this one, okay? To I over exponential I over 2 minus over 2i, okay? You know what's my goal here? I'm looking for this one. You see it? That's why I'm doing this one. I taking the upper term on numerator, we divide by 2i. As I'm dividing over 2i, I have to divide on the bottom over 2i as well, okay? So what is this? This is sine I n over 2. This is sine of 1 over 2. I did nothing here, okay? Just I switch the term, I put it on this way in order to find sine. That's it. So the sum of I theta from 1 to n equal, let's put this one inside in this one. If you multiply this one, it gives you, let's put it in this way to make everybody clear and understand. So this one you go, and we are using the same exponential. So let's factor this one and minus, let's cancel this one and this one, okay? Yeah, this is I, this is minus I over 2, that's mean I over 2. So let's cancel this one, put in this one, and put it I over 2 on the front. So put it n plus 1, that's it. That's what I'm doing here. So this one become I over 2 n plus 1 Okay, this one is a sine of what? Of n over 2 over sine of 1 over 2. This is n over 2, and the bottom one is sine 1 over 2. Okay, now I want you to follow with me here. So what is this? This is this one, exactly. Okay, let's put it as you see it. Exponential I over 2 n plus 1 equal cosine n plus 1 over 2 plus I sine n plus 1 over 2. Okay, just we are following these equations. Okay, so this one become cosine, okay, cosine n plus 1 over 2, okay, plus I sine n plus 1, this is the number complex, okay, and multiply by this term, which is sine n over 2 over sine 1 over 2. I'm looking there now for the real number and imaginary number. Okay, the real number of what? Of this one, exponential, last sum of exponential a theta, theta from 1 to n, equal what? Real number, equal this one. This one multiply this one, of course, because this is depend on this one depend on this one. So this one equal cosine, okay, cosine. This one, the real number of this one is first is this one. Is a cosine theta, theta from 1, and this is the image. This is the real number. Real number of this one is this one. Imaginary number of this one is this one. So let's take this one, put it here. That's it. So equal cosine n plus 1 over 2 multiply by sine n over 2 over sine 1 over 2. Okay, this is the first one, first expression. We already prove it. So let's go to the second one. Imaginary number of what? Of sum of exponential I theta, theta from 1 and equal what? Equal this one. Equal sum sine theta, theta from 1 to n equal what? Equal this one. Equal sine n plus 1 over 2, okay, over sine 1 over 2, right? I think everybody understand, right? It's very clear and simple. So if you like this video, thank you very much. I see you in next video. Bye.